Every data center in America, every hospital, every skyscraper in Phoenix, Atlanta, or Miami, every movie theater where you escape the summer heat, every server that keeps the internet running, every factory in the South. All of them depend on one invention that most people have never thought about. The story of how it came to exist starts with a printing company in Brooklyn losing thousands of dollars because their colors would not line up. And the 25-year-old engineer they hired to fix it had absolutely no idea he was about to reshape civilization itself. Now that is a story worth telling. Picture America in 1900. When summer arrived, the country essentially shut down. Federal employees in Washington worked half days from June through September. Movie theaters closed their doors entirely during hot weather because audiences simply would not sit in stuffy, overheated rooms. Entire businesses operated on what they called the summer schedule, which was really just surrender to the heat. The rhythm of American life was dictated by temperature. In the South, productivity plummeted every summer. Commerce slowed to a crawl. Whole regions were considered uninhabitable for much of the year. Growing up on the farm, we did not have this. And I can tell you, life was different. People planned their entire existence around escaping heat. Wealthy families fled to mountain resorts. The poor simply endured. Children slept on fire escapes. Workers started their shifts before dawn and quit by noon. The South's economy remained stagnant partly because of climate. You could not run a modern factory when your workers were collapsing from heat exhaustion. Think about that for a second. An entire region of the country economically trapped by weather. Some brilliant minds had tried to solve this before. Dr. John Gorey received the first United States patent for mechanical refrigeration in 1851. He was treating yellow fever patients in Florida and desperately needed to cool his hospital wards. His machine worked by compressing air, partially cooling it, then allowing it to expand. The idea was 50 years ahead of its time. But Gorey could not find investors. He died broke in 1855, his cooling machine forgotten. Without precise humidity calculations, early cooling attempts were expensive, ineffective, and often made indoor air worse than outdoor air. The technology existed in pieces. What was missing was someone who understood that cooling air was only half the equation. Willis Carrier was born on a farm in Angola, New York in 1876. Rural upbringing. Practical mind. The kind of person who fixes what is broken rather than dreaming about changing the world. He graduated from Cornell with a mechanical engineering degree in 1901 and took a job at Buffalo Forge earning $10 per week. In July 1902, the Sackett and Wilhelm's lithography company in Brooklyn had a problem. Their 4-color printing process kept misaligning, ruining thousands of dollars worth of jobs. The humid summer air was causing their paper to expand and contract unpredictably. Colors that looked perfect in the morning were completely off by afternoon. They called Buffalo Forge. Buffalo Forge sent Willis Carrier. This was not about human comfort. This was pure industrial problem solving. Carrier tried the obvious solution first: water sprays to cool the air. It was a disaster. The sprays added humidity instead of removing it, making the printing problem worse. But here is where Carrier's methodical mind kicked in. He realized the fundamental issue was not temperature alone, it was moisture. Here is where it gets really interesting. Carrier understood that he needed to cool water below the air's dew point to extract moisture, then reheat the air to the desired temperature. On July 17, 1902, he created what he called his rational psychrometric formulae, mathematical calculations for predicting exactly how air would behave at different temperatures and humidity levels. This was not guesswork. This was engineering precision applied to atmospheric science. The Brooklyn Printing Company's colors lined up perfectly. But Willis Carrier had no idea what he had just started. Nobody had any idea what they had just started. By 1904, word was spreading through industrial circles. Carrier had installed his atmospheric control systems at the Wayside Inn Silk Mill in Gastonia, North Carolina. Thread that had been breaking constantly in humid weather suddenly held strong. Product quality improved dramatically. For the first time, Southern textile mills could compete with Northern factories year-round. This was the beginning of the South's industrial revival. Though nobody understood that yet, the textile industry became air conditioning's first major market because humidity directly affected their bottom line. But the real breakthrough came in 1925. The Rivoli Theater in New York became the first air-conditioned movie theater. Audiences who had been staying home during summer heat suddenly packed the cool theaters. Within 3 years, over 300 theaters nationwide had installed cooling systems. Think about what this meant. Before air conditioning, movie theaters were seasonal businesses in most of America. Hot weather meant empty seats and closed doors. Cool theaters changed social patterns completely. They gave people a public place to escape the heat. Families made evening trips to air-conditioned theaters a summer ritual. The concept of the summer blockbuster was born from the simple fact that people would now go to movies in July. But theaters were just the beginning. In 1928, the Milam Building in San Antonio became the first fully air-conditioned office building. 21 stories of cool, comfortable workspace in the Texas heat. This proved something revolutionary. Vertical construction could work in any climate. Heat rises, and upper floors of tall buildings had always been miserable in hot weather. The Milam Building changed that equation permanently. If you could cool a 21-story building in San Antonio, you could cool anything anywhere. The era of the modern skyscraper city had begun. When you have been around long enough, you start to see how everything connects. Air conditioning was about to trigger the largest internal migration in American history. In 1951, more than 430,000 room air conditioners were sold in the United States. That was up from just 74,000 total units in the entire previous decade. The Korean War boom and mass production had finally made home cooling affordable for ordinary families. And that changed everything. Between 1950 and 1980, Phoenix grew from 106,000 people to 789,000, a 639% increase. Houston expanded from 596,000 to over 1.5 million residents. These were not gradual changes. These were demographic explosions. Cities that had been regional outposts became major metropolitan areas in a single generation. The Sun Belt was literally uninhabitable at scale before air conditioning. But here is the part that nobody saw coming. This was not just about demographics. This was about political power. Between 1950 and 2000, Sun Belt states gained 29 electoral college votes, while Frost Belt states lost 31. Political scientists have documented exactly how air conditioning-enabled migration created the conservative coalition that dominated Republican politics for decades. Northern Democrats watched their power base literally move south. Southern Republicans gained congressional seats and electoral votes. Willis Carrier had inadvertently helped reshape American politics by solving a printing problem. By 1960, air conditioning had created an estimated $1 billion annual industry. But more importantly, it had enabled $32 billion in Sun Belt economic development. Entire industries that could not exist in hot climates suddenly became possible. Data processing centers, electronics manufacturing, pharmaceutical production, modern hospitals, all of them required precise climate control. Air conditioning did not just make hot places comfortable, it made them economically competitive. Willis Carrier died on October 7, 1950 in New York City. He was 73 years old. He never saw Phoenix become a major city. He never witnessed air conditioning reshape American politics. He never saw the residential cooling boom that would make his technology as common as electric lights. There is profound irony here. The man who made the Sun Belt possible died just months before his invention triggered the transformation he had made possible. Today, Americans use more electricity for air conditioning than the entire continent of Africa uses for all purposes. 375 terawatt-hours annually. That is roughly 13% of all electricity generated in the United States. We have become completely dependent on the technology Carrier invented to solve a printing problem in Brooklyn. Modern American life would be impossible without his humidity calculations from 1902. But here is the twist that Carrier could never have anticipated. Air conditioning now contributes approximately 1.95 billion tons of carbon dioxide annually worldwide. That is roughly 4% of global greenhouse gas emissions. We have created a feedback loop where cooling demands increase as the planet warms from the energy used for cooling. Carrier's invention to control climate has become a driver of climate change. The technology that made hot places livable is now making the entire planet hotter. That is the thing about great inventions. They solve one problem and create an entirely new world. Sometimes that world comes with problems the original inventor never imagined. But that does not diminish what Willis Carrier accomplished. He took a practical problem and found a scientific solution. He turned atmospheric science into industrial application. He made the impossible possible. And nobody had any idea what they had just started. If stories like this fascinate you, hit subscribe and join me every week as we explore the inventions that changed everything. What invention should I cover next? Let me know in the comments below. Remember, this video is for educational purposes only. Always do your own research.